Hey guys, it's Mr. Dugal, and today we're going to talk about volume and volume of prisms specifically. One thing I want you guys to think about and get used to is the fact that we said in an earlier session that all of area revolves around the simple concept that it's its base times its height. That includes rectangles, that includes squares, that includes parallelograms, that includes triangles, that includes trapezoids, that all of these shapes revolve around the concept that area is base times height in some regard. The same can be true about all volume of prisms, and that is that volume is basically the area of the base, the area of whatever the base is of the prism, times the height. And I write here that when I refer to height, it's a third dimension, and we're referring to the stickyality. And we'll get into that in a second. We're going to first revisit area, and then I think finding the area of all of these bases, once we draw the height in, will help us to visualize the concept that volume is really the area of the base times the height. What I do see some students do in middle school math is that they will try to memorize 1,000 different formulas rather than understand the concept of area and volume. There are formulas that go along with these, but I'm going to work on us understanding the concept. So basically the area in this case, we said it's the base times the height. So the base is 12 and the height is 5. So the area of this rectangle is 12 times 5, or 60 square meters. And the second one in this square, we know it's a square because of these little tick marks. That means the sides are the same. You'll see up above, these have the same tick mark, and these have the same tick mark, which means these two sides are 5, and the other two sides are 12. So here we go. The area of this square is, each side is 7 yards. So since it's base times height again, the area would be 7 times 7, or 49 square yards. Finally, we have a triangle here. And we said in an earlier session that if I were to extend this to a rectangle, the rectangle would be 4 by 3. So the rectangle would be 12, which makes each triangle 6, because 6 plus 6 is 12. So the area of the triangle is 6. And that leads to the formula that there are 2 triangles in a rectangle. So the formula must be base times height divided by 2, or half of the base times the height. Again, the base is 3, the height is 4, which makes the area 6, because 3 times 4 divided by 2 is 6 square feet. You might say, Mr. Dugal, what is even the point of this 5 feet here? I would care about that 5 feet if I was doing perimeter, but a good way to think about that 5 feet is it's a fake height. I tell students that you never go to the doctor's office and the doctor never says, hey, could you stand diagonally against the wall? Right? We never say, I want to know what your diagonal height is. Can you stand diagonally against the wall? And I want to see what your height is. You would look at that doctor like he had lost his mind. You would say, you want my height? I need to stand up straight. I need to stand up straight for my height. You don't want my diagonal height. My diagonal height isn't my height. So that's the case here. We don't actually use that diagonal when using area. Okay, now to transition into volume. Okay, you'll notice that as I transition into volume, I will have added a third dimension, and this is why I call it the stickyality. I've added a dimension to make these figures stick out, and I know these aren't perfect drawings, but we're going to go ahead and pretend like they are, and pretend that these sides are each proportional, even though I know they're not. So we have, when I go to find volume, I need to take the area of the base. So the area of the base, in this case, the base was a rectangle. And the okay, so now I need to take the area of the base, each base, and in this case the area was a rectangle. And this shape here is a rectangular prism because its base was a rectangle and its other faces are also rectangles, which makes it a prism. So I'm going to take the area of the base, 60, and multiply by the stickyality. It sticks out by 4. The height is 4, so I'm going to just take this 60 here and multiply by 4, and the volume is now 240 cubic meters. So that's how you find volume. In this case, the area of the base was a square, and the area was 49. You'll notice that they all have this mark on them, meaning that this is actually a cube. They all have the same side lengths. All the faces are squares. And the volume in this case is 49 times the stickyality, which is 7. 49 times 7 is 343 cubic yards. Lastly, my last base here was a triangle, which again will make this a triangular prism because the base is a triangle. All prisms are named after their base, triangular base, a rectangular prism. This is called a cube, but it could also be called a square prism because it is a square base, and then its other sides are technically rectangles also. So we have a triangle with an area of 6. The stickyality is 7. So the volume in this case would be 6 times 7, or 42 cubic feet. So all of area revolves around the concept base times height, and similarly, volume also revolves around a concept, and that concept is area of the base times the height, or the stickyality. Hopefully this helps. Thanks so much for watching. So area is to base times height, just as volume is to area of base times height, or the stickyality. Hopefully this helps as a foundation for volume. And again, the aim here is to not necessarily memorize a ton of formulas, but to know the concept of why volume is area of the base times the height. Thanks so much for watching. Hopefully this helps moving forward.